Great. Okay, so yeah, I'm Thomas, and my colleague Charlie is with us. He's been kind enough to join us now, because I actually told him like a couple of hours ago. So he's here with us today, and I think he will be your mentor. If he's not, someone else in the team will be your mentor in the next 2 weeks. So I assume that all of you have read the description of the challenge, or is that your final decision? Have you chosen this challenge, or are you still, deciding what challenge you want to do? Well, I assume everyone has chosen the challenge. Okay, let's try to make this session interactive. So you can ask us questions about the challenge. Do you all have the document, the description of the challenge?
Yeah.
Yeah. Who doesn't have the document, the description of the challenge? Pratik, do you mean that you have it, or you mean you don't have it?
Yes, I have it.
Okay, wonderful. Yeah, so yeah, let's use this hour. You can use this hour as the way you want. Just ask us questions about, anything that isn't clear, or any ideas you have. Yeah, we're here for that.
Hello, Thomas. Can you hear me?
Yes, I can. Yeah.
Okay. Thank you for this challenge. Actually, we shape a team with 6 people to do this challenge. I would like to know more about this challenge and make it clear what is supposed to do in this channel. It is only about the background theory, as you said, or no, not. We should, for example, make a model and train the model, for example, to recognize the words and something like that. Make it clear, please, about the challenges. Sure. And yeah, thank you.
Yeah, sure, absolutely. Very good question. So yeah, we try to design the challenge in a way that, and I guess Charlie can elaborate after that, but in a way that it's going to be interesting for various levels. Of course, you all need to have some basic command of Python. I assume that at least most of you have a basic command of Python. But apart from that, some of you will have no knowledge at all about quantum mechanics or, category theory or linguistics. Some of you may have not some knowledge in one of those 3 fields, or several of those 3 fields. And so for those who have or machine learning as well, that's a very important one actually for this task. But if you have no knowledge at all, I think being able to reproduce. So the challenge is structured as a step-by-step. There's like 6 sub-parts in the challenge, and being able to do, from part 1 to 4 is already a good achievement for someone who has like a very limited knowledge in the field. And for the people who've already done, for example, classical NLP before, or who have, some good understanding, good command of mathematics, and have a good understanding of the theory behind it, maybe we could expect the person to maybe even develop their own model and maybe work out their own Ansätze. Ansätze are hypotheses that you use to build your model. And so the challenge is structured in such a way that it's a step-by-step thing, with increasing difficulty, and we don't expect everyone to be able to create their own model at the end, but if you're able to at least replicate what is taught to you in the challenge, this is already a good achievement for the beginners. And of course, for the more advanced, explore. This challenge is really about research. If you're interested about the world of research, if you're interested about fundamental research, this challenge, I think we believe this challenge will be very, very interesting to you, because you'll be able to explore and do more things. I don't know if that answers your question.
Yes, thank you for the clarification. Thank you.
And of course, generally, just do not hesitate. So it's going to last for the next, it's going to be during, it's going to last for the next 2 weeks, right? So we'll be available on Discord. I think there is like a 1 hour per day availability. So, just make some progress in your own time and reach out to us. We'll be very happy to answer your questions. And please do not be shy. There are no such thing as, because right now I see, okay, Maha, I'll let you talk in a minute, but I see that, it's 23 of us in this room, so 21 of you participants, and most of you, I mean, you've been courageous to ask your question, but most of you are silent. Please ask questions. It's very, very important. It's really important for you, because it's by asking questions that you will make progress in this field. And I suppose that if you've chosen that challenge, it's because you are interested in this field. So really, please ask questions. There is no such a thing as a dumb question. If it makes you more comfortable, I can stop the recording, but honestly, just ask questions. So Tessa.
Thank you.
Yeah.
Okay, sorry, had to unmute myself. But hello. I had a few questions. One of them is that it is mentioned in the paper that there is a data set present, and which consists of 100 sentence pairs. I'm not entirely sure, maybe it has to do with the setup of the environment, but where can I find this data set?
Yeah, I've actually answered the email. So Jade sent us an email saying that a few participants asked the question. First of all, actually, I realized that Maha also raised hand before. The thing is, when you raise hands and then it disappears. Can you please write your name in the chat when you want to ask a question, so then I keep track of who wants to ask questions. To answer your questions, so we've sent a data set. So Charlie found a data set, and we send it to you. It's also a data set that is directly accessible from LAMBEQ. So LAMBEQ is the tool that you will be using to do the challenge. It's a toolkit that we developed to do quantum natural language processing.
Okay, well, very good to know. Thank you. And second part, as you mentioned, these are different tasks, and according to your level, you can choose or get how far you want to go. And in the end, I think of all of us, it's expected to have a particular presentation. What kind of deliverables are you expecting from us?
So in terms of format, I don't know if Jyoti was here for a second. She disappeared. In terms of format at the end, I don't actually know. It's Womanium. I'll ask Womanium for the format. But in short, prepare a few slides explaining what you did, depending on the length of it. So if it's like only 5 minutes, just show your results. Maybe just show the approach you took. You can even think about, since it's a business hackathon, you can even think about a use case. I don't think it's mandatory. I think if you explain your approach and explain the results that you have, maybe have a slide on what you would like to do to improve. Typical like research presentation. What we've done, the results, and what we would like to do in the future. That would be great. But reach out for the precise, length of it, how many minutes you need to talk, and the exact format of the deliverable. I'd say I would ask Womanium for precise.
Clear. Okay.
Cool.
Thank you. Yeah, that was it for now.
Okay, good. As I said, feel free to shoot questions whenever you want. So yeah, Maha, you were first. Sorry.
No problem, and sorry for confusing you about lowering my hand. So sorry. Okay, actually, I had the same question about the data set. I was actually, I have already asked that on Discord, and I think Vadren cascaded that question to you. And regarding the data set. And my second question is regarding the model. I have already implemented a variational classifier, but for ordinary data set for numerical values, you know, but I've never worked on an NLP model before. So my expectation is it's very similar. I mean, it's gonna be a variational classifier, but for NLP. Is that a good expectation, or it's a little bit different?
I'll let Charles.
I'll take that one. It's a little different. So with LAMBEQ, what you actually do is each word is a set of gates that can be put into a variational algorithm, and then the structure of the sentence determines the structure of your circuit. So you train sort of a group of variational circuits made up of shared gates effectively, and then by the end you can build new circuits with these trained gates that will hopefully classify your sentence how you want. So a simple task and a general task you might use LAMBEQ for is something like sentiment analysis, and you'll have a bunch of sentences that share words between them, and by training these variational circuits to output, you know, the probability that it's a good sentence or a bad sentence, you can then build new circuits for new sentences that will hopefully classify it. But it's not one circuit that you put different inputs and train. Group of circuits with shared gate parameters. And I don't know how much that helped you. If you have more, please ask.
Okay, so it's gonna be a one circuit for each group of sentences. You mean, I think there are two group of sentences, the cook and the IT. So we are going to implement one circuit for IT and one circuit, or it doesn't work like that.
It's one circuit per sentence, but the parameters are shared among the sentence circuits. So by training one sentence, you provide information for the other sentence circuits because you'll share the parameters. A lot of it is done behind the scenes for you in LAMBEQ, like if you implement a model with a set of diagrams. But I mean, if you initially you can play around with I think we provide a notebook that you can look through, and you'll notice that each diagram, each sentence has a diagrammatic form. And these boxes in a diagram, these are little PQCs, basically. Each word is its own very small parameterized quantum circuit. And the grammatical structure of the sentence determines how you connect all these little PQCs up to make one big one for your circuit, for your sentence, sorry. And then, so you have a circuit per sentence, but with shared parameters. And so by training them, you train all of them, and then you can build new ones. But it's a lot of it's behind the scenes in LAMBEQ, but it's a circuit per sentence. But the very important thing to know is the parameters are shared, because otherwise, you know, if the parameters aren't shared, training one sentence has no effect on any other, and you could train them all to perfectly output the thing you want. But you're trying to teach it to learn sentiment. So multiple circuits, shared parameters.
Okay, that's for the training. I have another question about the encoding phase. When we translate the sentences into quantum states. I have a quick look at the resources, and I can say that a verb gonna be translated into a Bell state, and a noun gonna be translated into a pure quantum state. Did I get it right, or it's not that simple?
So, so what happens initially is you take your sentence, you do a grammatical parse, which gives you this structure, and then so a noun is generally, it depends on your ansatz, because the ansatz determines a lot of this. But with the standard IQP ansatz, a noun is a ket. It's a zero, no, a bra rather, followed by 3 rotation gates on a single qubit. So if your noun is Alice will be encoded as 0 followed by 3 rotations. So it's an arbitrary state depending on the parameters of your gates. Then a verb is generally connecting multiple qubits that are nouns. So it will be something like a C0 plus some rotation or a controlled rotation gate. And that's sort of how you build up your circuit. So if you have a noun phrase like Alice walks home, there'll be a noun for Alice, there'll be a noun for home, they'll be connected by the verb, which will be some sort of controlled rotation depending on Alice and changing home or something. And then you will get an output. And the post selection is done. So you'll have a single output wire generally, which you will measure to then get, some sort of probability. So if you were trying to classify whether a sentence was about Alice or Bob, you'll try and train your circuit so that if Alice is in it, your output may, when you measure it, be 1, and when it's Bob, when you measure it, it's 0. But so you don't really encode your sentence as input. You encode your sentence as a circuit rather than as input. I think if you read, there's a paper called, I don't want to set you guys a reading list, but it's like compositional models of language or something. I can link it in the Zoom chat, but that might help. Or QNLP in practice is the other one. I don't know if that helped you, but I will try and link this paper as well. Yeah, this one.
Okay, thank you. My last question is about the output of the circuit. In variational classifiers, the output is a label, is a 0 or a 1, but for NLP, I'm not sure what is should be the output of the circuit.
Depends what you're trying to do. So in our task, in the task we give you, and this isn't a task you have to do. If you can come up with your own one that fits within the framework, that's great. But the task we give you is a classification task, each pair of sentences. I think you're going to tell us whether they're talking about the same topic, cooking or IT, or whether each sentence in the pair is talking about a different one. So one is about cooking, one is about IT. And so the output, yes, should be a 0 or a 1. It should be a or a probability of whether you think they're both talking about the same thing or talking about different ones. The task we give you is a binary classification. But you can do a more complicated one. You could do a binary, you could come up with your own data set. You could do a binary classification of sentiment in like single sentence tweets maybe, or you could do multi-class classification. So, but the one we give is binary. Your output should be a probability that they're about the same sentence, that both sentences are talking about the same topic.
Okay, thank you. That's all from my side. Thank you.
Great. So Familiarity, you had a question as well. Yeah.
Yes. So you were talking about that we should focus on the fundamental research, right? And I was, you gave the PDF and the tasks which we have to do. And I was asking if there are some questions in more detail which you could share with us, because like if I have a specific question, then I would work more in detail towards it. So if you, for example, you proposed of creating your own reader or to optimize the circuit. So is there some more detail we can focus on?
I think if you do all the tasks in the PDF, in the challenge description, and you experiment with it, then you'll have specific questions about things that are maybe not clear for you, or things that you would like to explore a bit more. And I think interacting with us on a regular basis, then you realize it will, organically, it will redirect you to maybe some of the most pressing challenges in this research. I don't know if this answers your question.
Yes, okay, sure. And I have one more question. Like, generally in NLP, we have, like in classical NLP, we have the NLTK packet, and we have like so many ways of classifying our data and so on. So I'm not very clear about quantum NLP. Like, do we have, can we also put a focus on that? For example, if I have pause tagging and I have already packages which classify all the nouns and verbs and so on. So is there some sort of application which we can also do in quantum NLP?
Can I briefly interject before continuing? Great having everyone here, and especially Thomas and Charles. I see all black boxes. This is your chance to really interact with Thomas and Charles, and for them to see you. After that, there will be a lot of interaction on the Discord in different time zones. So please, Somya, Maha, Rania, Tessa, Pavan, Mustafa, Joseph, all put on your videos. This is the moment that everyone can see each other. You can see each other within the team. Thomas and Charles can see you. They have a face when you ask your question on the Discord. So great. Thanks, Tariq. Thanks, Mustafa. Please, more people, all put on your videos. And before asking the question, please introduce yourself so Thomas and Charles know your background. And yeah, great big group here. It was a really popular challenge, and we needed to move some around because this challenge was exploding, Thomas and Charles. So it's really amazing, and we have an amazing group here. Yeah, thank you all for turning on.
Thank you very much, Maluk. I try to ask, but I think people here in this channel are a bit shy. But I'm honestly, if you want, I can turn off the recording if that's what makes you shy about turning on your video. Please, if so, please let me know. You can even send me a direct message, and it's fine.
If I could answer the question that came up before. For the most part, at the moment, LAMBEQ is good for doing semantic level questions. So what is this sentence talking about? What is the meaning? Parts of speech tagging and stuff, I mean, no, that's easy to do classically. It's not something you would find easy to do with LAMBEQ at all. You can use pre-processing parts of other natural language pipelines to clean up your sentences, to make them nice before you put them into the LAMBEQ parser. That will all should work as standard. But in terms of the sort of tasks you can do with it, because it's such an early field, for the most part, we are focused on meaning and the semantics of sentences, and not lower level tasks like parts of speech tagging, parsing. So LAMBEQ does do the parsing for you, but that's done classically. That's not quantum.
Okay, all right. And I have one more question about the data set. So our group is having the maths and music data set, and we need the IT and food data set. So could you maybe share the link, or I don't know, the data set once again, so we all have the same one?
Yes.
Yeah, this is something again. It's Thomas is actually not in LAMBEQ. I got that wrong, but I provided it to Thomas. He's provided it to the organizers. I can maybe upload it here. I don't know if that's okay in the chat.
I'll try uploading it here. Actually, I have it here.
But yeah, it's just a text file with like 100 text pairs. But we will try and provide you that ASAP. Doesn't seem to like me uploading it that much though. Okay, Thomas, if you could upload it to the Discord. Someone said it's better to do it there, and I'm not sure I'm in it yet.
Yeah, I'll do it in the Discord. Just after.
Yeah. Okay.
And
cool.
I have one more question. So, like, if we were at the very beginning of developing LAMBEQ and like on a semantics level, and in the future, like, what is the main goal? Like, is it like, for example, summarization of text, or machine translation, or information retrieval? Like, could you give me some information?
That would be very long-term goal. These are you're very good observation, because these are some of the possibly the most difficult tasks in NLP right now. So as you probably observed rightly, we're actually focusing on one of the simplest NLP tasks, which is sentence classification. As we said, it's a research field. So it means that there's so many things to do, and it's also an opportunity for you to be creative and try to investigate other applications. Maybe you'll feel bored with classification. Maybe you can actually explore other simple NLP tasks and see what you can do with it. This challenge is really room for you to push the limits of science. I mean, already by using LAMBEQ, you will be, so already by doing all the steps in the PDF, you will be at the frontier of where science is in the field. So in this way, it's possibly one of the most exciting challenges here. You'll be doing, you'll be at the state of the art and possibly pushing it if your skills are sufficient.
Okay, great. Thanks for answering my questions. I will get back to you if I have more. Thank you.
Yeah, please do. Please do. So Shauria, had a question.
Yeah. Hello, I'm Shauria. So my question was, I wasn't here for like the first few minutes of, or the first few hour of this. So the first hour of this. So my question is that what exactly are you looking for, in terms of the criteria that you're going to be I guess grading off of or checking off of when people submit their challenge?
So yeah, so the question was asked before about the format of the deliverable. So for the format of the deliverable, which is one thing, the people you need to ask to is Womanium. I don't exactly know, but expect something quite short with a few slides in which you explain. So it's a research challenge in which you explain what you've done, the results, and potential ways of improving what you've done. But that also is dependent on your background. If your background is very elementary, command of Python and no knowledge of quantum computing or linguistics, then already going through the tutorial is a good achievement, is a very good achievement. If you have more some background in research or in linguistics or in artificial intelligence or in machine learning or in quantum computing, then maybe your challenge will be can you invent new things, perhaps? Can you create new ansatz, new models, stuff like that? I don't know if Charles wants to add something.
So yeah, in terms of, I think 2 weeks, most people will get through the tutorial, the 6 steps with our data set, and then in terms of extensions, it's, yeah, as Thomas said, finding other semantic tasks that you could try would be fun. We had another team at a hackathon. They did I think they called it their quantum bullcrap detector, where they took sentences about quantum computing from the websites of people like Goldman and stuff, and then they tried to get it to classify whether it was a real sentence about quantum physics or a marketing sentence. So that was quite a fun one. Other stuff you can do, as Thomas said, you can try a new ansatz. So an ansatz is how you build your circuit. It determines if it's a noun box, what gates you should put in. So the standard one we do, like I said, is just 3 rotations. If it's a verb, what you should do, should it be a controlled Z rotation? It could be a controlled X rotation. It could be a C0 followed by some single qubit rotations. So you could experiment with those. There are some papers that have come out with ansatz for this sort of stuff. You can try one of those. I will see if I can find that one as well. That was quite a good one. You could try a reader. So the readers are sort of how you parse your sentence in the first place. So we have grammatical parsers based on combinatory categorial grammars. Have ones that are very simple. They just chain the words together like this. So there's no grammatical structure at all. So you'd expect to get worse results, but you can try comparing them. That would be great. You could try making a new one. There's lots of ways to extend it, but also just getting through the first 6, that's also a good achievement. But anything you can present. So you can present your results from doing the tutorial. You could present results from trying out your own reader. Maybe it works, maybe it doesn't. But anything you can try is great.
That sounds awesome. Thank you.
Any other questions, or maybe we should do a small round of introductions?
Yes, thank you so much, Thomas. I was just going to say, if you guys run out of the technical questions, please, 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 these are incredible folks from the quantum industry. Introduce yourself, and I mean, I hope they'll be open to it. You can ask them kind of whatever you want about quantum, as hopefully specifically something to do maybe along the lines of NLP, but I'm sure they have opinions on a variety of other topics. So please get to know your mentors.
Jyoti, I have a question for you, actually, that's been asked several times. So what is the final format of the presentation during the demo day? And what are the deliverables at the end of the challenge, actually?
Yeah, so for the technical challenges, the first thing is if you guys ask for anything specific, and other than that, the expectation is the upload of your code to the GitHub, which Verdun went over, right? And during demo day, a slide deck. So that is why you'll notice, like on the deadlines, it was, just to make sure I don't say any date wrong here. The 23rd, the submission deadline, that is for your code, your technical submission deadline. When you say that the 24th is the demo day preparation, we're giving you that day to really prepare like the slide deck and the presentation that you'll be showing on August 25th. You could, I guess, include snippets of your code if that was part of your presentation, but essentially you will be judged on your actual deck and presentation. And also, we're having you submit your code a day before, so the mentors have time to kind of check and be like, yes, they actually coded what they said they coded, just as a sanity check. So presentation, code to GitHub is probably what it's going to be, unless they ask for anything else.
And how, thank you very much. And how long is the presentation going to be? 5 minutes or?
Sorry?
5 minutes?
I think that it was, the last discussion we had was about 10. We are revisiting that number just because we had finished balancing teams recently. But yes, it's a pretty short presentation. Probably it's going to be between 5 to 10 minutes. But the official announcement on that and prizes is coming very, very soon. So take it with a grain of salt for right now.
Okay.
Any other questions, by the way, that got brought up that I could maybe try to answer?
Seems like no. I think, oh yeah, Neil.
Yeah, so hello everyone, I'm Neil. So I just started the introduction before my question. So my background is in machine learning. So I'm working as a machine learning engineer at the moment, and got interested in the quantum computing field just, I think, starting last year, because I joined the Qiskit Global Summer School which focus on QML, and then also this summer school which also focus on quantum simulations, and also joined Womanium program. So everything quantum for the past years for me. So yeah, my question is more on the structure of the consultation. So what is the schedule? Is it the same time slot as we have right now, and then, or can we just have or asynchronous, like the format of the consultation with the mentors is like asynchronous, most probably? Can you shed light on that? Thank you.
So yes, so there'll be like an hour a day during weekdays. But we can proceed asynchronously, in the sense that send us message, send us questions as they come on Discord. I'll set up a room, if it's not been done already. I'll set up a room on the Discord, so we can you can send us questions there. You can also send us direct messages there as well.
Okay, so direct messages also encouraged. Right. Okay. Yeah, thank you very much.
I guess Charles and I could introduce ourselves. I can, and then everyone else it would be great if everyone else can give. You don't have to say everything about your life. You just can say your name and your background. Well, I think what is interesting is just the level of expertise you have, and of course you can talk more, and you can talk about your ideas of why you're interested. Actually, tell us why you're interested in this challenge. I think that's a good point to talk about. So I'll start. I'm Thomas Cervoni. I'm working at Quantinuum. My background is theoretical physics as an undergrad, and computer science and business as my master's. I don't have a PhD. So that's already one thing, you don't need a PhD to work in quantum computing, although it's usually necessary. They recruited me because I had this sort of dual, science and business background. And I think like for people who are not sure whether they want to do a PhD, I think mixing business and science sometimes can be a useful combination. What am I doing at Quantinuum? The title is evangelist. I don't know. We're actually thinking about changing that title. But right now, so yeah, basically what that means is I'm doing outreach. So I'm meeting companies, meeting research research groups to talk about the research we're doing. And so I'm obviously involved in events like this one. And yeah, that's it. I've been working at Quantinuum since January. Charles?
So I joined like 5 months ago after I finished my master's degree. I was a computer scientist, mainly machine learning theorist rather than quantum guy, but I had done some quantum stuff. I had a friend at the company who told me that he'd been really enjoying it, and I thought it sounded really interesting. You get to do, because it's a sort of startup and a research-based one, you get to do a little more research than you would at maybe a different company immediately out of university. So that was my main thing. I wanted to keep doing research, and I thought it would be a great place to do it. And yeah, it has. It's been really good. Apply. That's what I'd say. A lot of fun.
Something to add, I think, is so Jyoti asked us, a little about, if we can say about how we got into Quantinuum, so for example, so I mean, Quantinuum has different teams, and as I briefly mentioned in general presentation, I think we're the largest. It's fair to say that we are the largest, so vertically, fully integrated and pure player in quantum. Of course, there are larger players, IBM. So IBM is one of our partners and investors, actually. IBM, Google, Amazon, all these companies are bigger companies, obviously, than Quantinuum. But they don't just do quantum. And as a company that only does quantum, we're the largest one. So we have a lot of different teams, from hardware to software to actually business cases. And so that's the vertical integration, and also I'd say horizontal integration, so different use cases. So we do stuff in secure communication, quantum random number generators, cybersecurity applications, quantum chemistry, and simulation. We work on algorithms, so it includes quantum Monte Carlo, partial differential equations, which are obviously one of the most useful thing in engineering. And we also work in quantum machine learning, and the team in Oxford, so where Charlie and I are working, is the most abstract and theoretical team in Quantinuum. So each team has different focuses, obviously, but also different culture. And the team in Oxford, we tend to only recruit people we know. And by that, I mean, when you're interested about the work we do, always reach out to us, talk to us, get in touch with us. Don't be shy. We like people who are not shy. And the cool thing about being shy is that actually you can decide to not be shy to some extent. So you can reach out to us, ask questions, and engage with us. And that's, I guess, that's how I got there. That's how Charlie got there. We reached out to the people in the team. We established a contact. It's all about contact. Getting in touch with someone, getting to know someone, and building a relationship. So yeah, I insist on this.
Can I just jump in here really quick to kind of get the intro momentum going, and also just kind of address something that inspired me based on what Thomas was saying. So, I was at QIP, which was one of the more technical, I would say, quantum conferences down at Caltech in California. And that is where, I met someone named Dominic at INQ. And he was new to the team, so I didn't know him last summer when I was there interning, and he was doing some quantum NLP work too, which is why I am especially interested now in quantum NLP. So I'm working with him this summer, and that's kind of just reaching out to him at the conference and talking to him was actually led to that incredible opportunity, and probably also a little bit of my familiarity with the company. So that's just a case example for the point that Thomas is trying to make, right? That connections are really, really, really important for collaboration and for your career. And so, yeah, definitely don't miss an opportunity. Yeah, and one question I just kind of had, so as a little bit of a background, right? I'm a dual major in engineering and business at Berkeley, in a kind of like management, entrepreneurship, and technology program. And so I've talked to a couple of the evangelists, one at Amazon, I believe Mark Jackson before as well. And evangelists always have such a, open-ended, I suppose, role. It's very dynamic. And so for you, Thomas, I was curious, what is kind of the vision that you personally work towards under the title of an evangelist? And for anybody who is coming from maybe a dual background, many of the folks in this program, have that. What any tips you have for balancing those and getting the best out of both worlds? So I think you and I'm building a background in that is both tech and business, and I think you also have that. So 2 questions there.
Yeah, and I also have questions and answers to before answering your question. But I remember, so I the first time I saw the notion of evangelism in tech was actually in Berkeley, actually, as well, when I met Guy Kawasaki. So I think he's the first person to have coined the term, right? Are you in Berkeley? Are you at the Sutar Jadai Hall for innovation? Oh,
yeah, they have a certification. So I am planning to get involved in that. But apart from that, there is this like separate undergrad program that involves College of Engineering and Haas.
Okay, that's a good one. Yeah. Okay, very good. And Dominique from IonQ, you mean Dominique Widows, right?
Yeah.
Yeah, cool. So yeah, we work together because he's also at Oxford and he's very good. He's very close to Bob Cooker, the head of the team. So yeah, this is a small world. Everyone knows each other, and so yeah. Again, I think an additional reason for getting in touch. So what was your question? So what were your 2 questions actually? Can you?
So kind of the specific vision you work towards as an evangelist, and how you've maybe maximized your duality of backgrounds to really do what you do well for people that are building dual background.
I think it's constant learning. I mean, obviously, if you have a PhD, that would definitely help you to have the basic knowledge. The thing is, I haven't worked in quantum for the past. I haven't been in touch with quantum in the past 4 to 5 years. So I really had to start again, not from scratch, obviously, because you don't forget the math, you don't forget the method, but I had to start again learning. So it's a lot of learning actually on a weekly basis. The business skills, you don't really lose them, I suppose, because these are more skills than knowledge. And so having worked in business position for the last 4 years, I don't think I don't think I needed to really catch up. You'll constantly learn while doing the job, I guess. I don't know if that answers your questions.
Yeah, it's a good way to frame it.
Okay. but I'm happy to talk, like I'm happy to talk more about this. So you would like to go towards these kind of roles in the future, or?
Yeah, and guys, by the way, everyone, please feel to jump in whenever you'd like. Anybody who feels like this might be relevant to them or wants to tangent off into something else. Yeah, so for me, you know, like the applications teams at INQ is very inspiring to me. I think that really being able to build the teams that are kind of geared towards whether it's in this era or like longer term, something that you can, you know, see the output for, something exciting that you can do with the quantum computer is what inspires me the most. And I've kind of seen how, at least because INQ is growing as a startup, that process has shifted from being a very technical person who's writing code all the time to more management aspects, and you know, as teams grow, etc. And so, like in the long term, you know, right now I'm focused on building technical skill. But in the future, I think I would really want to better understand how to build teams, how to build products that are kind of around quantum applications, because that is a process that I'm noticing from conversations with folks in the industry is becoming a little bit more defined. And definitely, I think at Quantinuum, like you were saying, you guys are pretty big, have a, you know, very well structured verticals, etc. So that's kind of where the question is coming from. And then I think, you know, eventually it's kind of scary, I feel like, even to say entrepreneurship within quantum, but that is something, it's a possibility, right? And a growing landscape. So yeah, some context.
Several things about that. So first one is, so Guy Kawasaki, I really remember, like, it's possibly the most interesting hour I had in Berkeley, actually. When he told me and a couple of classmates that so when you say you're building technical skills for now, I think you're doing the exact right thing. And he was telling us, after you do your undergrad or master's, after you've built, you know, a basis of technical skills that you feel satisfied with, of course, you're never going to be fully satisfied. It's only going to be like you have to constantly build on it, especially in quantum. Once you have this basis, let's say this critical mass that you're happy with, he says, go and learn to sell. Don't go to Goldman, don't go to McKinsey, don't go to Google or the other tech company, and then unless you want to do something specific, let's say related to quantum in some of those companies. Instead, he said, even go to a car dealer and learn to sell cars. It's never going to play against you because it's, especially if you come, like, you know, for Berkeley, or if you have a strong technical background, is not working, you know, 6 months at a car dealer and let's say 6 months at another, you know, for another kind of sales place, is not going to play against you. You know, no one is going to be like, oh, what a waste. No. You're going to develop skills that most, like, if not the vast majority of technical people don't have. And this is the killing combo. If you're both good technically and you're a good salesperson, you're lethal in the industry. To say a negative word, but like, let's say lethal positively. You're very good in the industry. And of course, we know technical people that have had commercial positions and vice versa. Business people who sell technical product, but none of these people are really good. These salespeople who sell technical product don't really understand those technical products, and in the vast majority of the cases. And the people who are very, very good technically are sometimes have commercial positions, but they're not really salespeople. And so if you can build this real dual profile, then you'll be very, 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 very good and in very high demand. So that's the first point. A second point is take your time. The cool thing about quantum is that, of course, a lot is happening at the moment, but we won't have a fault tolerant, useful quantum computer in the next 5 years. No, we're not going to have that, and everyone knows it. I mean, no one knows when. That would be just wet finger in the sky, of course. But this industry is going to, I firmly believe, it's possibly going to be the largest industry of history of humankind, but it's going to take some time. So you have the time to develop the skills at the pace you want. You have the time to be very good technically, Not just, let's say you're interested in QNLP, not just in QNLP, that you have the time to read and build a basic knowledge in other aspects of it, because everything is going to interact. And yeah, I would say mostly these two things I would say are my piece of advice. And yeah, a third thing I'd say is it's linked to entrepreneurship, what you're doing. And I think out of all the business disciplines, I think entrepreneurship is possibly, but I might be biased, but I think entrepreneurship is possibly, especially at Berkeley, because they teach it particularly well. They've had this tradition for teaching it for the last, I don't know, few decades. Entrepreneurship is possibly the best discipline to learn, to develop some good business acumen. I think the lean methodology, the fact that and it's funny because I mean, scientists are some of the most rigorous people. I mean, let's face it. And because they've been trained, and there's nothing, they've been trained at being rigorous. They've been trained at building arguments and in a logical and rigorous manner. But when it comes to business, somehow people tend to forget that when you deal with the human world, you're dealing with a lot of assumptions. And I think entrepreneurship, especially at least at Berkeley, teaches you that. It teaches you that whatever plan you're going to make about your future venture, about the launch of a specific product, or about what customer wants, is going to be a series of assumptions. And you cannot possibly reduce them to certainties. That's not possible. So you only have to build a vision of the world that is, composed of different assumptions, and just being completely aware that these are assumptions, and work with this sort of mindset in uncertainty. And scientists are really good at that. But what's bad is that they're not taught that they should apply the same mindset when they do business, if they do business. And entrepreneurship is very useful. And especially in quantum, we have so many uncertainty about how the industry will look like in the future, that if you want to have some business background to your technical background in quantum, I think the entrepreneurship one is a very good one to have, strategically speaking. I don't know if I was clear. If I'm not, let me know.
No. I mean, I thought that was really, really. Oh, not raise hand. I was going to put clapping emoji. That was great advice. Thank you so much, Thomas. And I believe that we had set the agenda for the rooms to be at least until too many time zones, like 13 more minutes, right? So I really want to give everybody a chance. Please turn on your videos if you're comfortable, to at least go around and do like your name, where you are at in life, if you're working, if you're in school, and that question that Thomas said earlier, why this challenge, right? That provides some context. And then if we should be able to get to that in like 5 minutes, probably small group here, and then we can maybe like go into questions. I think Dimple has had a question here for some time. So does that sound like a plan to everyone?
Yeah.
Awesome.
Let's go.
Okay. Can I?
Yeah.
Go ahead.
Okay. My name is Dimple Mewara, and I've explored quantum, I will not say recently, but yes, during the pandemic, through all different kind of challenges in summer school. So it starts with the basic of quantum. And yes, last year, I think Neil mentioned about the summer school on ML. So I explored that. And recently for this Quantinuum QNLP, the thing was, I was aware of the AI and the not much the technical part, but about the NLP. And I was like, okay, how this kind of, I mean, when we talk about the everyday language, I mean, how quantum computer is going to play a role in kind of exploring. So yes, exploring LAMBEQ, the Python library, and not a specific question, but just a kind of, as you mentioned in the chat, yes, there's one paper which we can explore about the LAMBEQ tutorial to how it works, how it goes on. So not sure about how many stages, but at least it would be interesting to explore this kind of quantum and the NLP mixture. So yes, let's see. Thank you for the challenge.
Thank you for introduction. What's next? Should I go like from the list of participants and I go alphabetically? Is that fine? So after, well, Emily introduced herself already. So Blazing Aristocrat. Are you here? Maybe not. Okay, Konstantin Drabo. Okay, I'll just go through the name, and when you're ready, you can talk. So, Adish, can you introduce yourself? Hello. We can't hear you. I don't know if you're speaking already. No. Okay. Isabel.
Oh, hello. Can you see my video? Does it work?
Yeah, it works.
Oh, okay. Hello. My name is Isabel Ha. I'm from California, United States. I'm a high school student, so I'm not like the most experienced, but I found out about like quantum during like quarantine around I think it was 2 years ago. I went into Qubit, and so through there I kind of just explored quantum computing, and it just became something I'm really interested in, and I kind of want to just explore more in and become better at. The reason why I chose this one was, I don't know, I like research-based stuff, so I thought this one would be a good challenge for me. I also I'm just excited to learn just in general and to gain experience in this hackathon.
Right. Thank you very much.
Hello?
Yeah.
Hello?
Yeah. We can hear you.
Konstantin, I got an internet connection issue, so I did not have time to introduce myself.
Yes.
And I'm Konstantin Drabo from Burkina Faso. It's in Africa. I'm Java champion. And this last time I was interested by quantum computing. And I started working on QuickSeq documentation when I'm contributing right now. And I'm also QuickSeq certified associate. So this is an opportunity for me to apply my knowledge and also share knowledge with people around the world.
Great. Thank you very much.
you.
Welcome to the challenge. Abhinesh Prakash, are you available to introduce yourself? Okay, I'll go quick. So Joseph or Joseph.
Joseph, yeah. So I'm a PhD student in physics studying Monte Carlo simulations of lattice systems. And I'm interested in linguistics and mathematics.
Okay, so that's the right challenge for you, I guess. Welcome. Maha, you asked a question before, but would you like to introduce yourself?
Thanks, Thomas, for this opportunity. I'm Maha from Egypt. I'm a PhD student at Enchant University, and I am with focus on quantum machine learning. That's why I was always interested in variational algorithms. And my first paper is currently under review, so I need your prayers and good wishes. So I hope it ends well. And this is also my fourth year in as a PhD student. So I'm currently finalizing my thesis. And if this paper got accepted, so it's gonna be the end of my PhD journey. Why I chose this challenge? Because it's closely related to my research field. I worked before with quantum classifiers, and I have zero experience in NLP, but I am so interested in learning about them. And I hope 2 weeks will be a manageable time to complete this task, but I believe it will be. You have provided very good resources, and we have everything we need to tackle this challenge. I have another question about the LAMBEQ. Does this interface with any quantum platform like Qiskit or Cirq, or it have to work with Ticket?
It interfaces with Ticket, which indirectly means that you can use it on any hardware architecture, but it doesn't interface directly with Qiskit. But one little word on Ticket: if you want to do, if you want to work on IBM computers, and actually Quantinuum, we are the second largest reseller of IBM quantum computing after IBM itself. So we're the largest non-IBM reseller of IBM resources. It makes even more sense to use Ticket than using Qiskit directly. And why? Because we've developed, and that's actually something that is very linked to the LAMBEQ challenge. The mathematical formalism that we use is called string diagrams, or it's one form of it. It's linked to ZX calculus, and this ZX calculus, which is diagrammatic mathematics, is useful when you want to do circuit optimization. And Ticket is possibly the best quantum compiler out there, because you give it a circuit and it rewrites the circuit in a way that it runs more efficiently on, and that it does that for every, for a lot of hardware architectures, of course, the IBM one. So if you want to run something on IBM, you will run it even faster. If you want the exact stat, I have the slide, I can show it to you later on Discord, but it will run it even faster than if you do it directly with Qiskit. So yes, you will have to, you don't necessarily have to, but if you want to go into the technical parts, it may be interesting that you know a bit how to use Ticket, but it shouldn't be limiting you in what you can do with LAMBEQ.
I suggest to
Do you agree, Charles?
provide a getting started. Can you hear me?
Yeah.
Okay. I suggest to provide us with a getting started with Ticket, so everyone which is not familiar with Ticket to have a fast start with it, because I've never used Ticket before, and
sure.
I
Very
know
good.
it's Python based, so this will not be a problem, but the syntax, of course, is different, the packages, and a quick start, getting started with it would be useful.
Okay, yeah, sure. Very good idea.
Sure. You shouldn't have to interact with Ticket directly at any point in this challenge. LAMBEQ uses it below if you want to do simulations with like a noise backend, like from IBM, or if you wanted to run it on a real machine. But if you run a machine learning task on a real machine, you're going to be here for years. So for the most part, you are going to be interacting only with LAMBEQ, which is better documented than Ticket is. I'm afraid Ticket has fairly poor documentation currently. If you're interested in it, sure, we can help, but for the most part, I think you guys will be kept at sort of arm's length from Ticket.
If it's not necessary to tackle the challenge, so it's okay to not have it.
Yeah. You shouldn't need it. I think with the LAMBEQ documentation, with the task, and with the task PDF, and with hopefully they've given you a bit of code from us to get you started. I think that should be fine, and you won't have to worry about Ticket's slightly odd syntax and stuff.
Okay, thank you.
next in list is Mustafa.
Hello, can you hear me?
Yes.
Yeah, this is Mustafa. I'm from Iran, and actually my background is physics, condensed matter physics. What I did in master thesis related to spintronics, how we can use spin instead of charge of carriers in our devices, non-electronic devices. It is good for to develop quantum computing based on spin qubits. It's applications in spintronic, and it's the goal of spintronic. After that, I became interested in quantum biology and how quantum will affect on biology, like in navigation, bird navigations, DNA mutations, and something like that. After that, I became interested in cognitive models, quantum cognition model, especially developing decision-making algorithm by quantum. And I know the most basic is information. This is the idea comes into my mind. It's basic. It's most basic. I don't know how to say. Even energy and matter. Information is very important. I think everything can be created by information. I'm really interested how information processed in our brain as a complex system. For example, there are many kind of processings in our brain. For example, visual processing, language processing, I don't know, audio processing. And I would like to use this information. I believe that if we want to make an algorithm more intelligent, for example, if you want to make an agent more intelligent and conscious and go toward the AGI, I mean artificial general intelligence, you need quantum processing because we have a theory, ITT, information integrated theory. It says that all information should be integrated, and with sequential processing, like classical processing, we cannot integrate information. We need a kind of parallel and I don't know, simultaneous processing. And this field is very interesting. I'm very interested in this field because I would like to know how information can be encoded based on quantum language and use, for example, some quantum rules like superposition and entanglement to make a whole from the informations to make algorithms more intelligent in to act or have action in more complex system. I think it is my interest to this project to participate, something like that. Yeah.
It's a very interesting reason. So talking about AGI is still, I would say it's beyond theoretical for now, but
yeah.
But I guess philosophically I see your point.
Yeah, I believe we need to reach this area, to reach this, for example, we need a kind of classical cannot, because we need a kind of simultaneous processing instead of sequential processing. We need gather all the information together at the same time and process them and make a whole. And quantum mechanics can it, for example, true, can make it true, I think. For example, this, this, for example, participating in this hackathon maybe can make a sense to me how language processing, for example, language processing is a kind of processing that happens in our brain, okay? We have language processing, visual processing, we have many of processing in our brain, but I think it's a kind of simultaneous processing. It's not a sequential processing happens in our brain. Yeah, I believe.
Yeah, I think it's a reasonable reason if that succession of word makes sense, but it's a reasonable reason to. It's a valid reason. It's a valid reason to at least explore it. I I completely,
Yes,
completely align with you on this one. Yeah.
Maybe on future we can develop a kind of a quantum artificial brain.
Perhaps.
Maybe.
But I wouldn't be able to say. But yeah,
Yes.
welcome.
Thank you.
Next in list is Neil, who asked a question before, but yeah, now it can be an opportunity to introduce yourself.
Yeah. So I'll introduce myself again. So I'm Neil. Currently, I'm working as a machine learning engineer / data scientist at a company in Japan. So my interests are in actually, I have a lot of interests, mainly on theoretical stuff like math, physics, and computing. So, and that's the reason why I chose the quantum NLP challenge, as it is the perfect intersection of those three fields. Yeah, so looking forward to working with you guys and interacting with you with the challenge for the next 2 weeks.
Very good. Thank you very much. Next is Pavan.
Yeah. Am I audible?
Yeah, you are.
Yeah. Sorry, my camera is not working. Yeah, sorry for that. Yeah. My name is Pavan. So I am from India. So right now currently I am doing masters in computational modeling and simulation in Technical University Dresden at Germany. So basically my background is related to the mechanical engineering domain, but I am planning to do transition to work interface of the quantum computing, artificial intelligence, and the HPC. So yeah, and why I chose this challenge, because basically I am planning to do my research project and thesis on QML. So that's why I chose this challenge. And also coincidentally, in this semester, I did one seminar on the NLP. So it's a kind of coincidence. So yeah.
Great. Thank you.
Yeah, thank you. Yeah, I have one question, but not related to the QNLP. So can I ask here or later?
I think maybe we can send us the question on Discord if you can.
Okay, fine. Yeah.
And then
Sure.
we'll answer in our when we have the time.
Yeah.
Good.
Thank
Thank you very much.
Adish wasn't able to talk, but he sent something in the chat to me, so I can just introduce him.
Yeah, sure.
He's Adish from India. He's a third-year undergrad studying electronics and engineering. He started in quantum computing this summer, and he chose this challenge because he was interested in applying quantum computing to real-life tasks in ML and NLP. Thank you, Adish, and shame about the computer, but good to meet you. I hope you can hear us.
Next, there would be the thing is the order of words of name keeps on changing, so I hope I haven't missed anyone. Pratik.
This is Pratik, and actually I am right now a data scientist in a software company, and right now I'm working in the NLP part as well as image processing. But I'm interested to quantum because like machine learning can be speed up by the quantum technology, that information processing can be done. Like in classical, there is, if you use the neural net, right? In that case, if you run a simulation, it will take time, but in quantum, it can be the neural net state will be less and the processing will be more. So that's why I want to learn that. That's the first point. And the second point, I took this challenge because I am familiar with NLP and linguistic. So I want to know how to imply that quantum in the NLP.
Okay. Very good. Thank you.
Thank you.
Next in line is Pritam.
Hi guys, so I am a physics grad student, but my research field is cosmology. Okay, so I'm new to quantum computing and then wanted to know like what people actually mean when they say they are doing quantum computing. So join this workshop, and then when starting to join the hackathon, so going through these problem sets, all of them are very interesting. But then when I land on this problem, and I see that in the problem description, people are using quantum mechanics to actually define the rules of language. So that's actually it seems really interesting to me. So that's why I chose this problem.
Okay, great. Thank you. Who else? Tariq? Tariq, are you here?
Thank you.
Yeah.
So, am I audible?
Yes, you are.
Actually, my network is not that much good. Okay, so I'm Tariq, and I'm an optical engineer. Right now, I'm working as an optical engineer in India, Hyderabad, maybe you know. So my main work here is to design the optical systems and cameras and some laser systems also. For my previous project, I have to design a camera, and I have to apply a image classification process on that. So for that, I learned that Python and that image classification and ML also as some of the part of ML. And that quantum computing, I was learning from my college time, before 2 years, and 2021 Kiskit summer school, maybe you know the machine learning one. So I was participant in that, and after that I participated in that BMW challenge, maybe you know that BMW challenge. BMW was entering in the quantum. So I was part in a machine learning challenge. Was that one was also on that image classification and to find the crack on the body of car or something and something like that. But we approach in that by the QVIT for the image classification. But unfortunately, we was not selected in that. But that was a good experience. And from that point, the quantum computing is it's become a crush for me. It's a crush, and that's something I have to go with this. But right now in India, there is not that much opportunity. So I have to go with my my core field, in optics only. It's also a good field, interesting and some maximum like that. I think that's why I joined the NLP part because I was familiar with the image classifications and all these things. That's why I joined that NLP one, and it seems interesting. And maybe the guys, the Thomas and Charles and all these things. Thank you for that coordination and that guidance and all these things.
Thank you for taking the challenge. And with the research we do in our team, we're actually now looking at quantum linear objects. So maybe some parallels with what you're with your background and what you've been working on. So yeah, good. Welcome. To finish, Yusra, are you here?
Hi. Did you hear me?
Yeah.
Yeah, I'm Yusra from Algeria. I'm a PhD student in computer science. In the last 2 years, I was working in bioinformatics and with methods like heuristic, genetic algorithm, and all this L1. And I aim to switch on machine learning. So I start my PhD on a subfield, which is NLP, to work with machine learning. So when I was learn about state of art, I found a few works in quantum version. So I was very interested on this file, and I aim to explore it more and more to finally decide if I choose to working on it on my PhD or it's not. So this is briefly.
This is a very good strategic decision. This is the best way you can know if you'd like to continue this or not. So yeah.
Yes, I think I will. I think I will.
Okay.
I'm really interested.
Cool.
Sorry,
Thank
guys,
you.
I have to drop off now, but good to meet you all, and I'm sure I'll talk to you again in the stuff. All right.
Yes.
Bye bye.
A few people
Yes,
have.
thank you.
I'd say yeah. See you,
Thank
Charles.
you.
A few people have joined, and unfortunately I'll have to go as well, but please feel free, as again I'm gonna repeat this, please feel free to send us questions on Discord. I don't know if Charles and I don't remember if we've already joined the Discord. If we haven't, send us question in 3 hours, especially me, I'll be available. And yeah, we're looking forward to hearing back from you and see all the cool things that you'll be doing during the challenge. You take care, all of you. It was a pleasure to meet you.
Thank you, Thomas.
Thank you
Nice
so
to
much.
meet you.
Thank you.
Thank you.
Thank you so much.
Thank you, Thomas. Bye.
Bye-bye.
Bye.
Bye, guys.
Bye.
Bye, guys.